First of all, we are going to talk about hardware integration and how it is different from software integration, and what are the approach we should take for hardware integrations, like what should be our first step and then the optimization steps. After that, I'll show demo for some of the hardwares which we have used in the past, like camera or a fingerprint scanner for eKYC purposes, and a Raspberry Pi for remote command executions. So yeah, we are going to talk about those first, and then I'm going to show you the demo for some of these. Okay, so as we know, the softwares are developed in agile methodology, which is a iterative process, right? But hardware development is kind of different, and it is in most cases it is a waterfall model with which it is developed. Because of it, there are some limitations, like let's say if we want to uh, enhance some capability or we want to add something, it becomes kind of difficult. And uh, in while integrating our software with the hardware, we need to be mindful of those limitations. Like there could be a case where, let's say, my camera is not performing some autofocus or something like that, right? So we need to be mindful of those hardware limitations while starting the integrations, right? And many a times the documentation for any hardware, be it camera or be it fingerprint scanner or whatever, right? The documentation is usually very poor, and usually what you see in their ads or whatever, like they'll just tell you, for example, for camera, they will tell you that the picture quality is wonderful, resolution is this and this, right? But they are not going to uh, tell us that what are the limitations in integration, or if the particular setup is not going to work on some of the OS, right? So we need to be mindful of those two, because at the end of the day, when we hit the this technical hurdle, right, then we need to be extra aware, right? So this is the main issue we face with hardware integrations. Recently, we got a chance to work with few, like we integrated few hardware components in a Windows application, which was developed with ElectronJS. So ElectronJS is nothing but it couples both Node and the browser. So we can use the Node capabilities for like file system, let's say, right? So we can use file system or any of the Node's abilities, and also the browser capabilities, right? Like I want to visit, or I can use plain HTML to show anything I want, right? So we had developed a Windows application which was created with ElectronJS. It was a kiosk-like application, and there we had used few hardware components, right? So I'm going to talk about my experience, or our team's experience, where what are the issues we faced, and what was the optimization approach we took, right? And also the complete solution, what we came up with, like how it works seamlessly in production after all the optimization and everything, right? So general approach for hardware integration should be that we should focus on the main capability first. For example, if I'm using or if I'm trying to use a camera in my application, then the first thing should be that the stream is coming on, or I'm getting the stream and I can show the stream, right? So this should be the first problem. And then let's say if you're facing some resolution issue, or maybe the size, stream size, right? So those should be, we should look at those problems as secondary. We should always focus on the incremental solution. We should focus on the core issue first, and then gradually optimize it. So this should be the first approach we should take. Sometimes there are cases where we hit dead end, and because of maybe OS incompatibility, or maybe some function is missing in our hardware. Because of that, we can hit a dead end. But that is not an issue. we should always uh, try to build a POC. I mean, we should prove our concepts first, and then obviously we should start the full-fledged integration. That I say is the general approach, and now I'm going to talk about few hardware we had integrated. What was our approach? What were the challenges we faced, and the final solution? As I said in the previous slide, that we should focus on the core issue and then gradually optimize it. But there can be issues in optimization as well. There can be issue with the first thing as well. I mean, we are not able to reach the core requirements as well, right? And then there can be cases where after everything we hit the red end, right? So I have chosen few hardwares which show this criteria that there are some cases where for the first time we were successful. The first hurdle was kind of hard, and then the optimization was hard, and then in case of printer, I'll tell you in some time that it was really hard and we had to change it. So I'll tell you that as well. So yeah, uh, integrating camera was kind of easy for us. Uh, so we use the Electron browser capabilities, as I told you previously, that Electron has both node and the browser capabilities. It essentially combines both. So we just use the browser's capability to use media devices in our application, and it can be any media devices. If, let's say, for example, I'm interacting with you guys, right? So I could interact via Microsoft Teams, or I could interact via Google Meet, right? There we see that we stream our video, we use our mic, we use our speakers, right? So these devices are available in browser. I mean, anyone can use it, not only me. We also can use it, right? So we use the same capability of the browser to use media devices. And if I talk specifically, there is a navigator object on the browser, which we can use in runtime to access camera, or be it any let's say input device, let's say audio input or audio output, etc. So our approach here was very simple. We started with the stream first. We focused on the core requirement. Once we started getting the stream on our application and we could capture images, right? After that, we moved on the next step, which was the optimization. Uh, Also, like with this browser or navigator object capability, we can set some fields like resolution or frame rate, like how frequent the frame should come from the stream, right? Also the latency, let's say I want to add some latency to my stream, right? And aspect ratio, etc. So this was our approach. We after the core issue was resolved, we focused on the optimizations, and we were successful in that. So I'll talk about few challenges which we saw. So one of them was getting the stream as per our requirement took some time. As I said, our focus was the core problem. After that, the getting stream took some time because it is always iterative, right? I mean, first we need to see if the video resolution is good. After that, we need to see the image we are capturing from the video stream is good or not, right? So this process took a little bit of time, and it was mostly iterative. Uh, again, we uh, again we saw another hiccup, which was autofocus. The camera we initially used was that did not have the autofocus feature. Essentially, we were using Intel's camera, and it had multiple features, but not this one. So uh, everything, the core, even after the core functionality was working fine, this was not working for us, and we needed this. So we had to use a different brand or a different camera altogether. Uh, so this is the kind of challenge I was talking previously, that we can hit dead end. I mean, it's not always the software capability or software integration issue. It can
So,
be
Nakul, how did you like? So you said that some of the cameras might not have this autofocus feature. So how did you handle this in the application? Did you like
yeah,
notify the users about this, the limitation, or like what was uh,
right.
the approach of handling this kind of limitation?
Okay. Yeah. So at the later stages, we wanted a functionality where I do not have to press a button to capture my image. Right, a customer can sit in front of the in front of the machine, and they can just we'll just click the pictures. So we wanted this functionality badly because while capturing the while clicking that button, user can kind of see on the button or somewhere else on the screen. Right? They the picture was not very optimal, right, for our purposes. So that's why the autofocus feature was required. And how we found out is, as I said, documentation was not very good for this intent camera. So we had to kind of connect with them, like, if it is available or not. So they just said that it is not possible. After that, we specifically for, we started this specific search for autofocus feature, which camera gives the best. I'm just forgetting the name, which was the camera module we used at the end. But yeah, I mean, that was our approach. I hope it is clear.
Yeah. Okay.
Yeah. Yeah, as I said, I'll show you the demo at the end.
Sure.
I'll
Yeah.
move on to the fingerprint scanner. So our use case was that we wanted to do Aadhaar eKYC for all the customers who come or use the kiosk. Right? So for eKYC purposes, we needed the fingerprint of the customer, and yeah, so obviously we need the fingerprint scanner. But it was a very specific kind of fingerprint scanner because there are multiple models or multiple builds available in the market.
Mhm.
But our purpose was not solved with any other scanner. We needed very specific scanner which can do KYC, or which can give us the data which is required for KYC. Right? So there are some UIDI approved device vendors. Uh, One we used was Mantra. Mantra is very much. Uh, it's a big player in India at least, and yeah, so they provide UIDI approved device. And what's special about this is that they have licenses from UIDI that this can be used as EKYC for EKYC purposes. And also there are some security mechanism which are incorporated in the device. So yeah, uh, we needed this particular device. So these devices, like you can take any brand, not only Mantra, you can take any brand, and all of them come with a REST API supported service. So they ship with their own service, which is called RD service, or if I the full form is registered device service. So this particular service exposes REST APIs, which are, I mean, REST APIs are very easy to use, as we all know. So this was fulfilling all our criteria. So we went ahead with this device. And I'll briefly talk about what registered device service is and how it kind of enables us to uh, use the fingerprint sensor. Right? So registered device service, as the name suggests, it registers the device on the UIDI servers or Mantra servers. Uh, it encrypts the connection, and once that is done, it gives us the right kind of data which is required for each device. So this is what the registered device service does. Uh, and also, yeah, obviously, wherever we are using the this device, we need to uh, set up this RD service in our machine. Let's say, for example, I'm going to use fingerprint sensor in this particular system. Then I have to uh, go to the Mantra downloads and just look for this RD service, and I just need to simple install next, right? So yeah, it is a one-time setup, and you don't have to do it again and again. It's a one-time setup. And as I said, this is a secure connection with Mantra servers. And let me talk about this aspect as well, the security aspect. So, for example, I'm using this service or this particular device. I'm using this particular device, and I'm capturing my fingerprint. Right? I can use my data, which was obtained from this scan. I can use this device for maybe 5 minutes or 10 minutes, right? And the same uh, data, if I try to use after 10 minutes, it will not be supported or it will give me the bad results. So this is the security, this level of security is required for eKYC verification. And we need the same kind of processes, right? So there can be a dead finger which can be placed on the device, but we don't want all those. So all these kind of security measures are taken in these ID approved devices. I hope it is clear.
Yeah.
Regarding the challenges, so it is a government Aadhaar API, and Mantra devices are no exception to this. The documentation was not very clear. The readability part, I think I should focus on it because the variable names to pass in this REST API, those are very much unreadable. I mean, there are uh, variables named like MC or just S like that, right? Or T like that. So those variables are not very much readable. And if you go to the mantras documentation, it is I don't think it will give any fruitful results. So this is the example of the kind of integration which I was talking about in the beginning. But the first approach itself was kind of hard for us to get to. I mean, the core problem was also not getting resolved very easily. So this is that example. Getting all the variables was hard, whatever was with the REST API. And the problem here is that, let's say, if values for my variables, let's say 2 or 3 variables are incorrect, then also I'll get some result. But as soon as I go for the eKYC, I'll get a failure result, right? And those also, like the responses also, you'll not get the clear idea that what exactly went wrong. They'll just say that something is wrong or data is incorrect, and that was the main problem. And getting everything right was the main challenge which we faced. At the end of the day, we connected with the Mantra support team uh, for some of the problems, and also we connected with some peers who have worked with fingerprint devices in past. Uh, yeah, after that, I think after few meetings, it was clear to us and how exactly we use the device for our purpose. So there is a blog on Tarantica's official site. Uh, there is a link given. I have explained everything in this particular blog, that what are the different API parameters and how to kind of use it.
Yeah.
Uh, I'll move on to the next part, which is remote command execution on Raspberry Pi. So I'll briefly talk about what Raspberry Pi is. So Raspberry Pi is a very small device for very small computer, which is like palm sized, and it is it runs on Linux or its own version of Linux, which is called RSTM. And it is a very small device. We can do many tasks on it. And nowadays, the Raspberry Pis are very powerful. So our use case was that uh, there was a uh, I should say, there was a robotic arm which had to be controlled with Raspberry Pi. So Raspberry Pi had all the processes inside of it, or it exposed some of the commands with which we can control the robotic arm. And our process had to call those Raspberry Pi commands for it to work. Right?
Mhm.
And this was the uh, Yeah, so Raspberry Pi was, I'll call Raspberry Pi as RPI in following instances. So RPI was connected on the same network. Let's say my system is connected to some particular network. And then RPI was also connected to that very network. Uh, so it was available on the same network. And we had to code the Python processes. I think the problem is clear to you guys. I hope. Uh, so the one more issue was that in initial iterations of this particular setup, as I told, that Raspberry Pi did not have the internet connection. It was connected on the network, but not to the internet, right? So we faced this issue as well because, for example, if we have the internet connection, we can do many things. Like we can expose some publisher subscriber model, uh, can send some commands over those publisher subscriber, and we can easily get the data back or executions back, right? This was our limitation that we did not have the internet connection initially. So our approach there was that we just SSH'd into the RPA. SSH is a basic, it's a protocol, it's a simple Linux command which is available for us. We can SSH into any system. For example, we use nowadays EC2, AWS EC2 is very common use case, right? So there also, if we want to run some scripts or we run some processes there, we need to do SSH. Likewise, for RPI as well, as I said, it is a very simple Linux machine. We can do SSH into that RPI and do anything essentially, right? So our approach was similar that we did this part programmatically. Uh, Putty, as you all know that it is a very famous SSH client. So it has a small part, sub part, I should say, called plink. So plink can be used to execute scripts while we SSH, right? So we use plink and executed, SSH into the RPI and then executed the Python processes. Uh, this was our approach. And execution is, plink is a executable file in Windows, right? It's a .exe file. To execute any exe or any command, we can use nodes child process.exec, right? So we use the same thing, child process.exec to execute this plink. And yeah, this was our approach, and it worked fine.
So this was the approach
Uh,
basically when you, with the limitation that you were, the internet connection was not available on Raspberry Pi. So
right,
you had to
right.
SSH into the Raspberry Pi and execute these commands.
Right,
Okay.
exactly. Yeah, so RPA was on the same network, so we could SSH into it, but it did not have the internet connection, so we could not do anything fancier like uh, we do in IoT devices like MQTT or let's say webhooks like that. So we could not do that. So this is obviously very limitation, so we had to use the link or some sort of solution without the internet. Uh, so yeah, I'll talk about few challenges. So, for example, uh, obviously it added the dependency of P-Link. Wherever my application is deployed, I needed P-Link, right? This is the obvious dependency, and it is obviously a problem with the deployments, right? With the automated deployments, and as I want to expose my uh, Windows application to clients, then they had to install the P-Link beforehand. So this was an obvious dependency. Uh, so how did we resolve it is by using npm packages. So there are very good npm packages called SSH2 for obviously SSHing into the RPA, and we use the another npm package called SCP2. So SCP is a similar sort of protocol over SSH. It is to secure copy. Full form is secure copy, and we can copy files from any of the system to any other system, right? So we did the same thing. I mean, we needed some files from the RPA, then we did the SCP. So yeah, we use the SSH2 and SCP2, which remove the dependency on P-link. We could directly SSH into the RPI programmatically and execute our commands. Another issue we were facing was the execution results. I mean, how do we get the execution results from RPI when the command, whatever we are trying to execute, is done, right? So this was solved by writing everything on the standard output. We wrote the execution results on the standard output in the Python process, obviously, which was running in RPM or Raspberry Pi. We wrote everything on the standard output, and we could. There are ways to read standard output, either by using SSH2, and also with peeling. Also, we could do the same thing. So it is not a problem. It is a very common use case. So we did that. Another issue is uh, we faced this 2 or 3 times in a span of 1 year, that the IP assignment was kind of messed up. What happens is, if any of the device connects to a network, then the network will assign some IP, right?
Mhm.
So similar case was happening here too. I mean, I'm connecting to a network with, let's say, my laptop, right? And I'm connecting my Raspberry Pi to that particular network. Then the RPA will also get the IP assignment. And as we know, for SSH, we need the IP or something to back it up. So we were using the IP directly, and with this approach, we faced a challenge that whenever we change the network or we try to use a different network which was earlier being used, in that case the IP was different from what it was previously. So because of that, we face this issue that we are not able to use the Raspberry Pi. In some of the cases, it happened. So yeah, ultimately, all of these issues were resolved by moving the RPI to the internet. Exposing the RPI to the internet. Uh, so it solved few problems for us. First of all, yeah, obviously the dynamic IP assignment, we don't need to care about the IP now, because we are subscribing to a different, or let me briefly explain it.
So yeah, I mean,
So,
basically you kind of put a broker in between and you were sending messages and the Raspberry Pi was listening to those messages.
right,
That,
exactly, right.
okay.
So yeah, MQTT is a protocol similar to HTTP,
Yeah.
but MQTT is very specifically designed for IoT devices, because IoT devices are very less in memory and process power, etc. Right?
Yeah.
So MQTT is very specifically designed for IoT devices, and we use the same thing because RPI is also no exception. It is a smaller device. It is not a complete computer at the end of the day, right? So we use the MQTT protocol for uh, issuing those commands. We so basically there is a broker, MQTT broker, which is placed. My system will send some messages to an MQTT broker, and essentially whoever is subscribing to it. In my case, the RPA was subscribing to the broker, so it got the uh, command that what exactly I want to do. It did perform that execution and sent back the same message packet on the MQTT broker. I was listening to it, and I got the message that everything is good and these are the execution results. So yeah, again, it removed the dependency on any of the SSH based issues like dynamic IP. So we do not have to use SSH2 or SCP2 after that. So this was our final solution. We went ahead with. Uh, I hope it is clear. Yeah, finally I'll talk about printer. So what are the issues we face while, in general as well. So what are the issues we face in while integrating printers, and what are the different solutions available? From the hardware perspective as well, from the software integration perspective as well. So first of all, our use case was that we were trying to print some receipts. Let's say we go to DMart, we buy something, we will get a receipt at the end of the process, right? So we were trying to do a similar thing that we were printing some receipts,
Mhm.
and we tried initially we tried both a photograph printer and a thermal printer. So photograph printer is exactly the thing which we used or we nowadays we use for printing our photographs. Let's say we go to any photograph show, right? They give us the print finally, right? So those prints are uh, they come out of the photograph printer, and a thermal printer is uh, exactly the thing which I was talking about in DMart. So black and white, narrow and long receipt, right? So those are the kind of prints we get with thermal printers. And technology, obviously hardware and technology is completely different for both of these. Uh, Different formats entirely and different results entirely. So we use both of these to see just how good the results are. So I start with the challenges of both of these. Uh, yeah, obviously this was one of the hardest for us to get right because even a small change will change the entire thing. I mean, the results are completely different. So this was completely hard for us. Uh, so what we had to do uh, for the prints to get right is we had to compare multiple formats, like I mean file formats I'm talking about, the file which is printed. We tried PDF, we tried JPEG and PNG, etc. And uh, for the photograph printer, PNG and JPEG were just good. They were fine. And for thermal printers, JPEG and PNG were not so good. And PDF was giving the best optimal results. And second thing is, uh, we uh, compared multiple sizes also, be it font sizes or in the prints, be it paper sizes. At the end of the day, little bit um, older fonts and little bit font size was I think ultimately 14 or so, so that the thermal printer gives us the good results. Because anything less than that will kind of just show the dots and it was not very clear. And also we had pictures in the thermal printer of the things which we give out, right? So those pictures were not very good for example, for JPEG and PNG. So yeah, at the end of the day, we went with PDF and
So Nakul, like all these issues that you were talking about, it was with the thermal printer or like both the printers that you are having this issue?
okay, I'll explain this particular point. So
Sorry?
photograph printer and thermal printer. If I compare both of these,
Mm-hmm.
as I said, the use cases, photograph printer is each print cost a little bit higher because obviously the paper itself is kind of thick and very
Okay.
fine, right?
Yeah.
And ink also is costly. So each print was kind of costly for us. That's why we were constantly comparing thermal printer because thermal printer papers are also cheaper
Okay.
and the printer itself is cost effective. So we were constantly because obviously the photograph printer was very nice, giving smooth prints with JPEG. Whatever we gave it, right?
Mm-hmm.
It, Regardless of the font sizes, etc., it was giving very fine prints. But the cost was the issue which we faced because if I go for multi-page print, cost was going higher. So we were trying for thermal printers for the entire time. So yeah, uh, thermal printers, as I said, PDF and the certain font sizes were getting good results. So again, the method we were painting with, because we did not have to kind of use some buttons or some tools to print. We had to do it programmatically.
Mhm.
So we had compared multiple methods how to do that. So there were multiple node libraries we tried out, like node print or print.js, etc. Like there are abundant of npm node libraries for thermal printer, very specific for thermal printer as well. But none of these were good, giving good results, uh, or either node, those were not programmable. Right? We can add only certain things or in a certain format for it to print. Also, we tried out the PowerShell commands. So PowerShell was giving the optimal results. I mean, for a long period of time, we were using PowerShell because the print quality was good and everything was, I mean, just working fine. And obviously, we could use the PowerShell commands. We could issue PowerShell commands programmatically, and it was working just fine. Uh, Another issue we faced is the printer settings. Obviously, when you connect a printer to a host machine, there are bunch of settings we get. For example, if I go to Windows settings and printers, etc. So there are host of settings we can change or we can use for any printer, matter of fact. So for thermal printers, also there were multiple settings. If I specifically talk about the challenges we faced was the paper sizes, right? Because the paper is 3-inch wide, but the how long it should go was not available, or it was those were the issues we faced. Again, one more specific issue for the page sizes was that for multi-page PDF, we were not getting good results because within each page print there was a huge gap, blank space, and it made no sense. So that was the another issue we faced. And this particular issue, what I talked about for the multi-page PDF, uh, we at the end of the day, after comparing many things, we went ahead with the single page PDF. So we shortened, I mean, for the PDF itself, we changed the height very, very. This is the content we had to print. We changed the PDF height itself, the PDF page height itself. And after that, it was working just fine. So if I talk about the final result, what we were using and how it worked out, is that we went ahead with thermal printers for cost-effective reasons, with the PDF format and with PowerShell. So yeah, this was the final solution we went ahead with. Uh, yeah, and for JPEG printer, as I said, it was giving just good results without too much I mean, many uh, settings or something like that. We used print.js node library, and with JPEG prints, the print was just fine. And I'll tell you the issue again with with PowerShell. So we faced the issue with PowerShell, and it was related to the page margins. So there were page margins on the left and right. So as I said, the paper was 3-inch wide, and even then we had some margins on left and right, and height issues, right? The print was kind of narrow sometimes, and it was a long-running issue. We tried many options with PowerShell as well, but we were not successful on those. So we use a Windows executable library. It is a CLI based executable library. That means we can use it programmatically or we can issue commands to it. So we use this PDF to printer, and yeah, again, like any executable, we used child nodes child process.exec to execute this library, and we just passed on our file path and the prints were just fine. And it increased uh, the the level of control we had. Uh, we could change anything. I mean, we could add margin, we could remove margin, we could change the height, etc. So the control was the main thing we got from out of this PDF to printer executable. This was the final solution we went ahead with.
Okay.
Any questions as of now?
No, I think you can continue.
Okay, sure. Sure. So the theory part is over. I'll go ahead and show some demos. And I mean, the solution we did, right?
Okay, so all of your code is available on GitHub, whatever you are going to demo.
Yeah, exactly. Yeah,
Okay.
it is available on GitHub and I've posted the links.
Okay.
First of all, I'll go ahead with the fingerprint setup.
Okay.
This is a React application. I did earlier the theory part that it is at the end of the day we get exposed to Raspberry. We can use Raspberry in React as well. So I just created a demo code piece here. And just starting the application.
So this is for the camera part, right?
This is for the fingerprint scanner.
Okay,
Camera, I
fingerprint
think
scanner.
I'll show.
Okay.
Camera, I'll show at the end. So just to till this application starts, I'll just revise the core issues we faced, right? So one of the main issue was the documentation and readability, right? And getting the getting all the variables exactly right for our purpose, right? So those were the core challenges we faced. And let me demo to you how it looks like.
So you have the fingerprint device attached to your computer.
Right, right. So as I said, there is a RD service which is required to run on my host machine. If you can see on the bottom right corner, you will see these kind of notifications from RD service. These are notifications from RD service, and we cannot control these. As you can see, I'm attaching the device. So you will see the device is attached and framework is ready to use. This is the second message. So what essentially this means is framework is basically our RD service. And I can start using the RD service now. Or I can start calling these APIs, right? So just to give you guys a demo, and I just remove the device. And for the demo purpose, yeah, you can see the first API itself for the RD service. I mean, obviously if the RD service is installed, I can call the REST APIs anytime.
Okay,
But
so
the
now,
result, sorry.
no. So you just disconnected that device, and now your application is showing that the device is not ready.
Right. Yeah. So as I said, REST APIs are always available. I can go REST APIs now itself. The result are the main thing that we need to look at. So for example, this first API itself, which gets the device status, it gave me the status of not ready. That device is not ready for use. Or any device is not connected or registered with RT service as of now. So I'm just connecting it back. Now I can see the framework is ready to use, and I just refresh my code. Yeah, I can see the device status is ready now. Once I get this result, I can I can further my process. I can capture fingerprints in it. Right? Again, there is a notable thing here is that we get uh, REST API paths in this particular API response. If you see for device details, there is another API. For capture also there is another API. So these are the parts we get inside the response. And essentially we should use these parts for further API calls.
Okay.
So second API is device details, and it gives me the device details, anything which is very unique for this particular device I'm using. So like model ID is 100%. These are the serial number, system ID, etc. Uh, and this is the main and uh, third API which is used for capturing. So I'll just start capture and I won't place my finger on it.
Right now it is.
Yeah, there's no finger on
Okay.
the scanner. So I'll just see the capture time.
Okay.
So that I just go the error code that it did not capture anything. And this time I am going to keep my finger over it, and I can see the error info is success and error code is 0.
Okay.
And similarly, Q score is a quality score, the quality of the fingerprint,
Okay.
fingerprint capture. And NM points are basically it's a biometric thing, and the points in my finger, how many points were covered in this particular scan.
Okay.
Anything above 25 is good enough.
So maybe you can try it once again, and maybe
Yeah,
you will get a different result
I'm
for now.
putting another finger. So this one I got the NM points is 63 and 24 is 68. Yeah.
Okay.
I'll quickly go through the code. I mean, I will not go through the different components and what we are showing exactly. I just show the API models, what we are sending with the API request, right? So this is the first API, and let me just show you the base layer. So this is the base layer for the RD service which I was talking about. All the REST APIs are exposed over this particular address only on localhost and 11100. So this is the port. These are default port. I mean, if this port is not available, you will try to get another port. So this is the base. This is the URL for this particular get device status. The first API which I just showed. Right? This is the API and nothing fancy again. Only
So
the
this
method.
API will basically return you which API to call to get the fingerprint and the device status data.
Yeah, and more importantly, it will give me the status if the device is ready or not ready.
Okay.
So only notable thing here is that method is different from usual HTTP methods. Usually we have get, put, post, etc.
Mm-hmm.
But the method name here is very different. It is RD service and URL is where it used to. So calling this API network type. I'll just refresh it. So if you can see the first API call, it goes to localhost 11100 and specific here. And this is the response we get. Obviously, we get the XML response. We need to kind of change it to JSON to use it. And
Okay.
the status is ready. This is the device info will be on path this, capture will be on path this, like that. So these are the details we get. And the second is info, device info, which I just showed you. So yeah, here the URL, as I said, whatever you get from this particular, the first API response, RD info, this is the exact URL we need to use with the user, right?
Okay.
And if you see the second API, the entire path, you'll see that this is localhost 2100 and then RD info. This is exactly what as a response from first API, right?
Right.
This is what we are doing, nothing fancy. Again, only the method name is device info, and again, this you get here, device info.
Okay.
I'll quickly show the response. You see that DP ID, RDS ID. So DP is a device publisher, I think this is the right name, who is I was saying this is the most important the most important API, obviously, because it captures the fingerprint
Mm-hmm.
and it was the hardest to get right.
Okay.
Method again, method name is different here. This is capture, and again the URL is obviously what we need to use is given here, RD capture.
Okay.
And this is the same thing we use. Again, if you focus on the data part, you'll see that there is a particular format we need to pass for capturing the data.
Okay.
Uh, if you see here, F count, F type, I count, P count, format, etc. Right?
Mm-hmm.
These are all the variables you need to get right. Also, there is a variable called bath, push, etc. Right? So I'll tell you the problem with it. So first of all, this is a very generic API, and it works with multiple device types. Not
Mm-hmm.
only the fingerprint scanner, it can work with iris scanner, iris in our eyes.
Yeah.
It can work with iris. It can work with uh, some other, I don't remember exactly, but some other device types also. So here the problem lies. We need to pass these values uh, very. Uh, I mean, whatever we are doing should match with these values. For example, F count here, F is for finger. F is to say exactly how many fingers I want to scan. Right?
Okay.
So I want to scan only a single finger, so I'll just pass one as the finger count. And again, the finger type, like if I want to specify anything, let's say I want to scan only this finger, then I need to pass the type. If I don't pass the type, then any finger is just fine. Or there is a different default value, obviously. And similarly, I count is for height is P, I don't remember exactly. So yeah, these are the values which were kind of hard to get. And again, I specifically want to talk about this path.
Mm-hmm.
Let me show you how these values are. So F count is 1, F type is 0, I count 0, right? PID version is the Aadhaar API versions. Timeout is, let's say I don't put my finger for 10,000 milliseconds, that is 10 seconds. Then it will give me that the capture was not successful. Push and load, then in environment is prod and home prod. P and P production. What is the value like? It was very strange that this is how the value is created. I mean, there are multiple eKYC options. This is very particular to the eKYC API,
Okay.
which are like version RA, RC. So as you can see, the variable names are kind of strange and not very readable. What exactly these means? You have to find the meaning of this and set the values. If you see the bar is combination of all these, we need to combine all these in a string, and essentially uh, at the end of that combination, we need to encrypt it in a very particular format, essentially 256, and after that base 64.
Okay.
These are the kind of things which we were not aware in the beginning,
Yeah.
and I was talking about the level of encryption, etc. is kept here.
Okay. So I
I'll
think
just
Nakul, yeah, I think you can move to the next demo. I think
sure, sure.
I run out
So
of time. So
yeah, sure, sure. So for command execution part, I'll quickly go through the code because I don't have the RPA connected as of now. So I'll just
okay.
quickly go through the code
Yeah,
and
sure.
exactly we will do it. So just to give you guys an idea that this is the Python command uh, which is run on the RPA.
Okay.
Sudo Python and Python file directory finding, etc. Right? So this is the command we wanted to execute on the RPA. But the issue is that we needed to execute it remotely. So if I combine it with plink, then I need to give my local plink file path and the SSH username, SSH password, and the IP, right? Without IP, SSH will not be successful.
Mm-hmm.
And then the command. So this was the command at the end of the day we were using. And I'll quickly show you. Uh, so once we have the command, the peeling command ready, we just use the exec. Exec comes from the child process to exec.
Right.
This is the feature, and we could just pass on the command, and once that is successful, we'll either get an error or we'll get responses on a standard output or standard error.
Okay.
So as I said, we could use these results for whatever you wanted to do, right? Another thing I want to talk about is how we can directly hit these commands. So if you see in these particular snippets,
Mm-hmm.
passing full commands with plink, right, in exec. But if you see here, we were passing only the part which we really need to execute. So this is the second part where we use the SSH to uh, node module, and you can see SSH to dot client. So
Okay,
this is
so
the client,
this is the node module that you talked about too, SSH2.
right?
So without the p-link part of the putty.
Right, right, exactly. Yeah. So we could just create a connection and we could pass the SSH values like IP username, password, right?
Hmm.
And when the connection is ready,
Right.
we were just, there is also an exec method on connection, SSH to connection. And we use that, we pass the command we wanted to perform, and then we'll get either error, we'll get the error.
Okay.
So due to some maybe SSH is more successful, or else we'll get a stream. Uh, for stream as well, I mean, we will get the data on this is the equivalent of standard output,
Okay.
and standard error dot own data is equivalent to standard error.
Okay. So
So
with the help of this, you are able to basically capture whatever is the output of your command.
right, right, right,
Okay.
exactly. So this is a demo application, and we are just also logging here.
Yeah.
Nothing
So
that we
maybe
can
you
see.
can show the like what is this command doing? Like maybe if you have captured any images, like what exactly does this command do in on the Raspberry Pi? So that
Uh,
we can have an idea.
okay, so uh, okay, so as I said, it is a Python command we want to run on the RPI.
Mm-hmm.
So RPI is kind of we had added some LEDs on it, right?
Okay.
And we were using Python script. I mean, I did not write the Python script, but essentially it was doing this. It was uh, sending electrical signals on those LEDs. So for specific GPI of what it was, that specific LED was blinking.
Mm-hmm.
So
Okay.
this was the script, and uh, I mean, yeah, this was it.
Okay.
And that was the Python script we were trying to execute remotely. So
Okay.
remote execution was the main part. Yeah.
Okay.
Okay. So I go to the uh, third part, which is
Mm-hmm.
camera integration. I'll
Okay.
quickly run you through guys the code, and then we can see the actual demo.
Okay.
As I said, we use the browser's capability of accessing camera, right, or
Mm-hmm.
any media device in that sense. So this is the main function which initializes the camera. So this is the main function. And if you see here that we are using navigated object directly here, right? Navigated
Yeah.
dot media devices and dot enumerate devices. So what this function does is it gives us the list of all the devices which are connected to our system or browser has access to.
Yeah.
Be it audio input, be it audio output. That means mic or speaker, and also the camera.
Okay.
So yeah, it will then enumerate all the devices, and then we can do basically anything. I mean, we can decide which device to access. Right?
Okay.
For example, I just wrote a simple filter on these values,
Hmm.
and you'll see we'll get a list of objects, and one of the object is kind. So what kind of media devices?
Okay.
For example, video input. Video input is camera, and similarly, audio input or audio output will get.
Sure.
And we don't have to limit ourselves to uh, label, but obviously I mean, we can do that. For example, I want to use that particular camera only, right? I don't
Hmm.
want use any other camera, there can be three
Okay.
cameras in the section, but I want to use only the particular specific camera. Right? So this is for that. This is to limit that camera label part. So I
Okay.
had just saved this camera label. That integrated webcam is what I want to use.
Okay.
And I mean, we don't have to do it. For example, in Google Meet, if you see, we will get a list of audio devices and video devices. What we want to use. We can go to settings and we can change it. We can change the default device itself. So this is the kind of setting we can use. And once we have a target device, we can use the media devices don't get user media. Get user media is what gives us the access to that particular device. For example, here in video, I have mentioned the device ID as the target device ID, and it will get me the stream for this particular device. And also, I can mention some stream constraints. Like I don't want the audio, I just want the video. Right? And for video, also as I had mentioned that we can set many things like frame rates. I can mention it minimum is this, ideal is this, aspect ratio, width, height, latency, etc. Right? We can define all the media constraints while accessing it, and basis those media constraints, I'll start getting the stream. As you can see in this particular thing, I'll get a promise
Okay.
stream wrapped in a promise, and I can just directly use the promise. For example, in a video HTML tag, which is placed here. In a video tag, I just did video.src object, and this is a string.
Yeah.
So this is a simple thing, and I just started getting my stream on the application screen. And very quickly, I'll just tell you that how to capture image from this video stream because it is not particularly easy or straightforward. So as soon as we get the video stream, then what we need to do is we need to capture those video bits in a canvas. So canvas is a HTML element. This is a hidden element where we are not showing it on the page. So we just need to capture all the bytes on the canvas first. And once we have the image on the canvas, then we can easily get the image. Yeah, this is the second part. So this is very specific that I want to draw on canvas from this video element. And these are the offsets. Offset is basically where to start from and where to end it, like that. So this is a for document. You'll get the documentation for canvas very easily, and yeah, this is the approach that we need to paint it on canvas and then get the image. Should I run this application again? I mean,
Yeah, I think you might have to turn off your camera for that, right?
Yeah,
so that is fine. I mean, you can just restart, start your application and
sure. I'll just
go to that.
disconnect the camera once.
Yeah. So I think he's going to run the browser, and on the browser he's going to capture the camera.
ElectronJS application. Sorry, I forgot to mention earlier that this is the ElectronJS application, and ElectronJS is obviously we are using browser capabilities, and we could use it anywhere. I mean, the functions I have shown you, the initialization part and the capturing part, these are basically browser functions, and we can use it anywhere. So this is of Electron application. It is a basic Windows application which is running. You can see here. And this is the part.
Can you scroll down, Nakul? I think your voice is breaking a lot right now.
You can see my screen now.
Yeah, I am able to see the screen. Yeah, just that the button labels are not visible.
Okay, sure. So as you guys can see, it is the initialization was successful, and I start getting my video stream in my browser or ElectronJS application.
Yeah.
And see it here. And the capture functionality is also added. I'll just quickly show you. Yeah. And I can just click on capture again, where I'm just reinitializing the camera. So when the capture is clicked, the camera is stopped. So now the camera is not working. So I'm just clicking again on capture again, and
Okay.
so this is a very simple.
So these all the images are now saved in that canvas part.
This particular one I'm not saving, but
Okay.
we can do anything. I mean, we can save it. We can save it via IP or something like that.
Okay.
But once we have the image object, we can do. I mean, we can save it in our local system.
Okay. So I think you can start your camera
So
now.
I just yeah, yeah. Yeah, I started my camera.
Okay.
This is it from the demo part.
Okay.
If you guys have any question, I can take it.